So let's look at another example of finding area of a triangle, but in this example, we need to utilize some graphing from Algebra 1. So we're going to graph three lines and then try to think about the triangle that's formed by them. So with graphing, we're gonna try to do this without like coordinate paper, like grid paper, I guess, and just try to maybe kind of eyeball what these things would look like and think a little bit about where they might cross. So we are going to have a general sketch of this. So there's my coordinate plane. Here's the x-axis and the y-axis. The first line is y equals 2. So remember, when we're graphing y values, that's up or down, that's a height. So y equals 2 is just going to be some sort of a horizontal line. Okay, so maybe something like that all the way across. These are all the places where the y value equals 2. So if I'm here, I'm at kind of 0, 2 as a point, but over here might be 2, 2, and way over here is maybe 10, 2, but every y value on that red line has a height of 2. Okay, our next line is x equals 6. So x is kind of moving left or right, and so now we're going to be looking at all the places where x, all the points where x would be 6. So that's going to be something that's a little bit more running up and down. So maybe something like this. Okay, so this would be the equation x equals 6. Okay, and then our last one is y equals 2x. And you spent a lot of time last year, I guess, thinking about that. This is in the form of kind of slope-intercept form. So I could even say this is y equals 2x plus 0. So my y-intercept is 0. It's going to go through the y-axis right there. And then 2 is my slope. It's going to be going uphill as I move from left to right. Now, I'm not trying to be exact with this graph at all, but all I'm trying to show you is that it's going to be going uphill kind of like that. So this would be y equals 2x. Okay, so we have all the equations there. So what I want to do now is think a little bit about where these things maybe cross. Well, maybe the first thing I should do is just highlight. Let's see if I can do this. Trying something new here. Okay, what I'm looking for is the area of this triangle. Okay, that's what I'm looking for. So I'm trying to add a few ideas there. And to do that, it might be helpful to find the coordinates of the corners, of the vertices here. So I'm looking for those coordinates a second. Okay, so the bottom right one's going to be the easy one because I already know the blue line is where x equals 6 and the red line is where y equals 2. So if I put that together, the coordinates here would be 6, 2. Okay, and then if I were to, I don't know, maybe go up to the top one, again, it's on that blue line, so I know the x value has to be 6. Okay, and what I'm going to be looking for is, well, what's the y value there? This green line will tell me because I know that my x value is 6 at this point. So if I plug a 6 in there, it's going to tell me the y value. So 2 times 6 is 12. So this would be 6, 12. Okay, and then the bottom left one, it's kind of where y equals 2 crosses with 2x. So if you wanted to, I suppose, off on the side, you could even say, well, one equation is, I don't know if I want to describe it that way, actually. If we just do a little guess and check here, what's going to make this line have a height of 2? So what would I plug into this to make this be 2, I guess? And the answer is going to be 1. If I plug a 1 in right there, 1 times 2 gets me an output of 2. So this would be 1, 2. Okay? If you need to talk to me about that last one, feel free to ask a question in class. So this is why this is useful, because now I have enough info to find the base and the height of this triangle. So if I were to just focus on the base right there, that's going to be my base, well, that's the difference in the x values there. I'm going from 1 to 6. My height, my y values don't change at all. So 6 minus 1, that means my base is 5. Okay? And then right over here, this would be my height. And that's going to be the difference of the y values. Okay? It's not moving left or right. 6's stay the same. So I'm going to look at the y values. 12 minus 2 is 10. Okay, so now I'll just kind of create some space right here. Area is going to equal 1/2 base times height. So 1/2 times 5 times a 10. And overall, if I put that together, I'm going to end up with 25 square units. Okay, so that's kind of just the thought process in that. You're going to have a few that you get to try on your own.